Hello everyone, welcome back to EducQuiz. My name is Chenta Gabriel, a third-year student at the University of Boya, the Department of Computer Engineering. So today we are back for a new chapter, a new topic, which is quadratic theory. So this is what we are going to do. This is the table of content. We are going to do an introduction to quadratic equations. Secondly, we will learn what is the discriminant of a quadratic equation. Then we'll see what is meant by real and distinct roots, repeated roots, complex or imaginary roots. Then we'll see the relationship between roots and coefficients of the quadratic equation. Then we'll see some useful relationship, some other useful relationship like alpha squared minus beta squared. See what is equivalent. And then we'll solve some exercises, I think. Some practical exercises you are going to solve. Okay, so let's start with the introduction to quadratic equation. So what is a quadratic equation? A quadratic equation is any equation of the form ax squared plus bx plus c equals to 0 or equal to anything or equal to 0. Ax squared plus bx plus c equal to 0. This is where I have to write it. Where a is not equal to 0. Here, b and c are elements of real numbers. So a, b, and c must be a number of real numbers, and a is not equal to 0. So a quadratic equation is any equation of this form. Example: 2x squared plus 5x plus 6. This is an example of a quadratic equation. So, the discriminant of a quadratic equation. What is the discriminant of a quadratic equation? Actually, the discriminant of a quadratic equation is b squared minus 4ac. There is a result of this operation. B squared minus 4ac is equal to the discriminant of a quadratic equation. So if you have an equation like x squared plus 2x plus 3 equals to 0, the coefficient of x squared is a. In this case, a equal to 1. The coefficient of x is b. In this case, b equal to 2. And the third is 3. If this was minus 3, c would have been minus 3. If you had minus 3, it's equal to 4. You cannot leave this one to be a number like 4. You have to bring it inside. That will be 4 minus 3 minus 4 equals to minus 7. In that case, your c will be minus 7. So you can find your a, b, and c when this is equal to 0. It must be equal to 0. So, yeah. In that case, what will be the discriminant? The discriminant will be b squared 4 squared minus 4a1c minus 7. That will be equal to 4 squared 16 minus 4 times 1 times 7 times minus 7. That will be plus 28. So if you add that is something like 30 with 14. So that will be 44. That in this case will be the discriminant. The discriminant is just used to describe how the roots look like. How do they behave? So the discriminant is used to describe if the roots of the equation is real and distinct, if the roots are repeated roots, or if the roots are complex or imaginary. Repeated roots here, you could say equal roots. Repeated roots or equal. Let me just write or equal. You could call them equal roots. So, yeah, that's quite it. So we look at the first one, real and distinct root. How is the root of an equation real and distinct? So, an equation has real and distinct root is b squared minus 4ac. Determinant is greater than 0. If b squared minus 4ac is greater than 0, like in the case of the previous equation, that was the discriminant was 44. So it is real here. It has real and distinct roots. You can see a case where the roots, they tell you that the equation has just real roots. In that case, you have b squared minus 4ac equal to 0. Yeah. If you see something like it has real roots greater than or equal to 0, you could see something like b squared minus 4ac. If you tell you that it has equal roots, like here, equal or repeated roots, you have b squared minus 4ac equal to 0. So this is for real and distinct. Roman 1, Roman 2, b squared minus 4ac equal to 0. This is for equal roots. We're going to take some examples where we solve equations that have those properties. So, well, let's just define all of them first. So, this is for equal roots or repeated roots. So, here you have complex or imaginary roots. So, if b squared minus 4ac is less than 0, you have complex. Complex or imaginary roots. So, this is it. So you have to master this. You have to know it in your head because I don't think it's in the formula booklet. I don't think. Maybe you might have this formula somewhere, but they will not tell you which one is real, distinct, complex, repeated. You get. So what is the relationship between the roots and the coefficient of an equation? So I didn't change this through the last time. Well, here we are on the relationship between the roots and the coefficient of a quadratic equation. So for a quadratic equation of the form ax squared plus bx plus c equal to 0, the sum, let the roots be the roots of this quadratic equation be alpha and beta. I don't know, I've always had some difficulties in writing beta. Well, alpha and beta, I think you can write it better than me. Okay, so let the roots of the quadratic equation be alpha and beta. If you want to write this in terms of their roots, you have ax squared. Well, if these are the roots of the quadratic equation, it means when you sum the roots, you have alpha plus beta is equal to minus b on a. That is alpha plus beta is minus b on a. Then alpha beta is equal to c on a. So that's the relationship between the roots and the coefficient of the quadratic equation. So these are the coefficients and these are the roots. We are letting this thing to be the roots. So if you sum the roots, the two roots of the quadratic equation, you have the result as minus b on a, which are the coefficients. If you multiply, if you do the product, you have it as c on a. So it means if you write this equation in terms of its roots, you are going to have you're going to have a x squared minus sum of root x x plus product of roots equals 0. Yeah. If you doubt, you could. Well, let's derive this. Let's derive this. Let's derive it. So if you try to derive it, what are we going to have? We're going to make B a subject formula and put here. Then make C here subject formula and put here. So B subject formula, making it here, you are going to have, we cross multiply, A will multiply here. We have A into alpha plus beta is equal to minus B. If you multiply all through by negative, you have the minus coming here. So B is this. You can replace B directly there. But let's make C subject formula first. Here we cross multiply, that's just all we have. A alpha beta. When we have this equal to C, we can replace it here and check if our formula was correct. We have A x squared plus B is, well, let's put the minus A into alpha plus beta x plus C is A alpha beta is equal to 0. Actually, the A won't be there. So I can see that A is common. I can just remove A everywhere. So if I divide all through by A here, I'm going to have alpha beta equal to 0. So in terms of its roots, this is how you are going to write the quadratic equation. Without the A here, there's no A here. So it's x squared minus sum of root x plus product of roots. So here it is. So this is the relationship between the coefficient of a quadratic equation and its roots. So we're going to see some useful relationships. Useful relationships we are going to have, well, alpha squared minus beta squared is equal to difference of two squares. Alpha plus beta alpha so well, but it's still good to know. So then you have alpha minus beta is equal to what? Square root of alpha minus beta whole squared, which is equal to what? Square. See that this is equal to this because if I cancel this square root can cancel this. So you can have it as square root of here. If I have it squared, I have alpha squared minus 2 alpha beta plus beta squared. So you can have it like this. If you rearrange it, you have square root of alpha squared plus beta squared minus 2 alpha beta. Yeah, so this A minus B can be developed this way. So the third one is alpha cube minus beta cube is equal to alpha minus beta. This is alpha minus beta into alpha squared plus alpha beta plus beta squared. So this is for alpha cube minus beta cube. And then that's pretty much all. So these are the things that are going to help you in solving quadratic equations or questions in quadratic theory. So let's dive into exercises. Some exercises here. So you also have to know alpha squared plus beta squared is equal to alpha plus beta all squared minus 4 alpha beta. I think it's 2. Yeah. Yeah, you also have to know this. So when you have alpha plus beta, it's the same like square root of alpha plus beta all squared. It is same like square root of alpha squared. This is in the case of minus alpha squared minus 2 alpha beta plus beta squared. So this is what you're going to have, which could be more simplified to have square root of alpha plus beta squared is this. So alpha plus beta squared, you have alpha plus beta all squared minus 2 alpha beta here. So you have written this. This is alpha plus beta. Now minus this 2 alpha beta. So you have this as, all of this is square root, please. All of this is inside the square root. In fact. So you have this as alpha plus beta all squared minus 4 alpha beta. So alpha minus beta can be represented like this. So for alpha plus beta, the same like square root of alpha plus beta all squared, which is equal to square root of alpha squared plus beta squared minus 2 alpha beta. This is plus even. Yeah. Well, you have to know this for alpha minus beta. So let's dive into some exercises. If we do some exercises, we're going to have, okay, exercise 1. Exercise 1 says, find the set of values of k for which the equation x squared plus k minus 3x is that a k minus 3x plus 1 equal to 0. Okay, so if you have a question like x squared plus k minus 3x plus 1 equal to 0, they ask you to find the range of values of k for which that equation is real and has real and distinct roots. So the equation has real and distinct roots. What do we say about real and distinct roots? So they ask you to find the value of k for which this equation has real and distinct roots. For real and distinct roots, we put solution. For real and distinct roots, for real and distinct roots, b squared minus 4ac is greater than 0. Which implies if you solve b squared minus 4ac, b squared minus 4ac is what is b? V is the coefficient of x. We will have b squared, k minus 3 squared minus 4 times a is the coefficient of x squared, 1. C is the coefficient of this. Well, c is the last value, the y-intercept when you are plotting a curve. So, well, that is 1. Yeah. So you have this as just minus 4. You have it as, let's expand this. We are going to have k squared minus 2 times this is 6k minus plus this square is 9. Then minus this 4 times 1 is still 4. That will be equal to, we can still simplify, we have k squared minus 6k, 9 minus 4 plus 5. Okay, so we have this, but we have to find the values of k for which this equation has real and distinct roots. So you can see that this thing can be factorized. I don't know, you can use you can use the formula. When you use the formula, you have k is equals to minus b, also minus square root of this on 2a. We are putting k here so that because we want to find k here. So our b here is minus 6, our c here is 1, and our c here is 5, and our a is 1. So that will be equal to, okay, so minus of minus 8 is 6, also minus square root of b square is 36, minus 4 times a is 4 times 1, times c 20. Hold on, 2 times a is 2. So that will be equal to 6 plus or minus square root of 16 on 2, or equal. So the two values will be 6 plus or minus 4 on 2. We'll first take 6 plus 4 on 2, 5, then 6 minus 4 on 2. So 1, 6 plus 4 is 10. 10 on 2 is 5. That will be the first value. 6 minus 4 is 2. 2 on 2 is 1. So the two values are 5 and 1. So here we have the values of k. Well, we wanted to put k in factor form. We'll have k minus 5k minus 1, k squared minus 6k plus 5. So we had the values as 5 and 1. So to have the factor, you just do the negative of the values and you put it in k next to it. So like this, just like this. So because we have 5 and 1, I'll put negative 5 here, minus 1 here. If I have minus 5 and 1, I would have put 5 and minus 1. If I have minus 1 and minus 5, I would have put 1 and 5. The order does not matter. You can put one before the other, just like that. So, but we know that the roots are real and distinct. So k minus 5 into k minus 1 is greater than 0. So you find the values of k for which this is greater than 0. So you firstly have, when you have this inequality, you will see how to solve this inequality in inequalities. Actually, there's a topic of inequalities. You'll see how to solve it there. So you have k minus 5 equal to 0. This is the first critical value, which means k is equal to 5. As for the first critical value, k minus 1 equal to 0. K equal 1, that's the second critical value. Well, this thing showed us the critical values actually. To have the factors, we put it like this. So when I find my critical values, I'll draw the number line and put my values, the smallest value first, then the bigger value, 5. Then I'll select a value which is less than 1. I'll take for instance 0 and put here and look at the sign. So when I put 0 here, I have negative 5, it's negative. When I put 0 here, I have negative 1, it's negative. Negative and negative will give me a positive answer. So every value here is going to be positive. Since the power here is 1, 1, another here is going to be negative and positive. So, since the question asks for the values of k for which that equation will be greater than 0, I'll take this and this. So these are the parts that will be selected. So the range of values of x. So how do I represent this? So the solution set, S means solution set, is equal to k such that here we can see k is less than 1. K is less than 1. Union k is more than 5. K is greater than 5. Write it like this, and that will be the correct answer. So hope the working of the first exercise was understood. So move on to the next exercise. So we see how to deal with exercises that deal with real and distinct roots. So for exercise 2, it is said, find the range of values of k for which the equation x squared plus kx plus k, x squared plus kx plus k plus 5 and 4 equal to 0 has real roots. So check here that in this case they are just real. The roots are just real, not real and distinct. So it is slightly different. So how do we solve this? You know that for real roots, what is the condition? B squared minus 4ac is greater than or equal to 0. In the case of just real, it's greater than or equal to. If it was real and distinct, then it would have been just greater than 0. So in this case, what is B? B is the coefficient of x, which is k. A is 1, C is all of this. All of what does not contain x nor x squared is C. It's considered C. So B squared in this case is going to be k squared minus 4, A is 1, and C is this, k plus 5 and 4. Greater than or equal to 0. Which implies, let's expand this, we'll have k squared minus 4k minus 5. When you multiply minus 4 times 5 and 4, you're going to have minus 5. It's greater than or equal to 0. So from here to solve this, it is inequalities, it's normal quadratic theory. So we can go to the inequalities video and find how to solve inequalities using formula method or any other method that was shown there. So which two numbers will I multiply to have? Minus 4, and when I add half, minus 5. Minus 4, minus 1. So I have k minus 4, k minus 1 is greater than or equal to 0. If you expand this, we see which is k squared minus 5k minus 4. Okay, let's do formula method. We have k is equal to minus b plus or minus square root of b squared minus 4ac on 2a. That will be equal to minus b is 4 plus or minus square root of b squared 16 minus 4ac minus 4 times a. 4 times a is 4 times c. C is minus 5. That will be plus 20. All on 2a. That is equal to 6 plus or minus root 36, 6 on 2. That will be equal to 6 and 5 and 4 minus 6 minus 2 minus 1. So we have k minus 5, k plus 1, k squared, k minus 4k minus 5. Okay. So here is a factor. When you have this factor like this, you have k minus 5 into k plus 1 equal is greater than or equal to 0. Greater than or equal to 0. So to solve this, I'll find my critical values. I see that my first critical value is k equal to 5. K equal to 5, yes. And my second critical value is k equal to minus 1. I can get them from here. These two values are critical values. So what do you do next? You draw a number line, put the negative 1, then the 5. So you take a number. I'll choose 0, which is in between here. And I replace it here and I see the sign. So when I put 0 here, I have minus, and I want to put 0, I have plus. So this is going to be minus, which implies this is going to be plus and plus. Then, since I want all of the values of x which are greater than or equal to 0, of k, sorry, which are greater than or equal to 0, I'll select this part and this part, which implies the solution set is equal to k such that minus 1 is less than or equal to k, union 5 is less than or equal to k. And that is the solution for exercise 2. So let's do exercise 3 and see how it looks like. For exercise 3, we have find the set of values of k for which x squared plus kx plus 3k minus 5 has no real roots. X squared plus kx plus 3k minus 5. This equation plus 3k minus 5 equal to 0 has no real roots. We should find the values of k for which this equation has no real roots. So till now we have done for real roots, then real and distinct roots. Then now they say no real roots. So in the case an equation like this has no real roots, what does it mean? It means it is complex. If it is not real, it means it is complex or imaginary. So if something is not real, it is imaginary. So in the case it is imaginary, what are we going to do? For imaginary roots, we have 2m, 1m, okay? For imaginary roots, for than 0. When the roots are less than 0, it means they don't exist. They are imaginary because they don't exist. They are less than 0. So in this case, what is b? B is k, a is 1, and c is everything that does not have x. In this case, 3k minus 5. So b squared is going to be k squared, which implies k squared minus 4a 1 c 3k minus 5 is equal to, should be less than 0. What is this here? So when I expand here, I'm going to have k squared minus 4 times 3 is 12k minus 4 times 5 is 20. It's less than 0. So from here I can do my formula method. I do my formula method. I have k as b minus b plus or minus square root of b squared minus 4ac on 2a. That will be equals to minus b is 12 minus 4 times a times c, 80, all over 2a is just 2. Yeah. So from here, just simplify. You're going to have 12 plus or minus 144 minus 80. Okay. 14 minus 8, 6. So this is going to be square root of 64. That is going to be on 2. That is going to be, the two values are going to be 12 plus 8, 20 divided by 2, 10. Then 12 minus 8, 12 minus 2 is 10 minus 6 is 4. 4 and 2 is 2. So these are the two values. So the factor is going to be k minus 2 and k plus minus 10. Both of them are positive, so you put minus and minus. And all of that is going to be less than 0. So let's check it. You have k squared minus 12k plus 20. Yeah. So when you have this, what you're going to do is you find your critical values. For the critical values, the first critical value is going to be k equal to 2. The second one is going to be k equal to 10. These are your critical values here. So when you find your critical values, you draw a number line. You put the slowest one first, then the biggest one, 10. A random number. I choose 0. 0 is less than 2. So 0 will be here. I'll be the sign here. So when I put 0, 0 minus 2 is negative. Negative 2. So it's going to give me a negative answer. So everything here is going to be positive. Everything here is going to be negative. Everything here is going to be positive. So since we want values of k which are less than 0, we take the less than, the minus part. So we take this part. So we can see that the part lies in between 2 and 10. So how is our answer going to be? As the solution set is k such that 2 is less than k is less than 10. Is how you leave it. Here you can see that it is in between 2 and 10. 2 is less than k is less than 10. So here we are done with exercise 3. Then I think we'll do one last exercise. Then we'll move to serious work. So exercise 4. Exercise 4 says, given that the equation k plus 1 x squared, k plus 1 x squared minus 3kx plus 4 into 1 minus k is equal to 0. Given that this equation has repeated roots, find the range of values of k, the value of the values of k. Yeah, so here it is repeated. And they say the roots are repeated. So for repeated roots, I could say equal or repeated roots, comma, b squared minus 4ac is equal 0. So it's not less than, greater than, or less than or equal to. It's just equal to 0. So in this case, what is b squared? What is b? B is the coefficient of x, which is minus 3k. This is b. A is the coefficient of x, which is this, and c is this. So let's get done. We have b squared is minus 3k squared minus 4 times a, k plus 1 times c, 4 into, well, let's expand this. When we expand this, we have 4 times y. 4 times minus k minus 4k. I expand it already just to not make it long. And that will be equal to 0. So we're going to expand this. We have 9k squared minus 4k minus 4. I can put the minus outside and just put 4k plus 4. Or I can just put the minus. Let me just multiply everything by minus. Plus, then minus 4k minus 4 times 4 minus 4k. So that would mean 9k squared plus 4k times 4. That will be minus 16k minus 4k times minus 4k. That will be plus 16k squared minus 4 times 4. That will be minus 16 minus 4 times minus 4k. That will be plus 16k. All that is equal to 0. So let me check this work. Yeah. Minus 4k. Yeah. Yeah. Okay. Minus 16k squared minus 16. Alright, so when we have this, then we can simplify further. We bring the right terms together. 16 plus 9 is 25k squared. Then we bring all of the k's together. Minus 16 plus 16 is actually boiling down to 0. Then we have minus 16. Yeah. It's equal to 0. So that would imply 25k squared is equal to 16, which implies k squared is equal to 16 on 25, which implies k is equal to square root of this, square root of 16 on 25, which is 4 on 5. And that due to the equality here is not an inequality, it's an equality. Something is equal to something means it has a unique value. So yeah, we have solved the fourth exercise. Okay, so then we can go to exercise 5. Exercise 5 is going to be an exercise that will actually have alpha and beta. I'm sorry people are like, so the exercise here don't have any alpha and beta, whereas in the GC you see alpha and beta. Well, I was doing that for you to know what are real, distinct, repeated, equal, and complex. You did all of these. If you master all of these, then you can go to the more serious ones which have the alpha and beta as roots. So let's take a fit exercise. Exercise 5. So given that the roots of the equation x squared minus 5x, x squared minus 5x plus 4, x squared minus 5x plus 4 equal to 0 are alpha and beta. The roots of the equation x squared minus 5x plus 4 equal to 0 are this. Find an equation with integer coefficients whose roots are a alpha squared and beta squared. Alpha squared and beta squared as a B, 3 alpha and 3 beta. Okay, this is actually B. Well, we'll solve it as B. A says 3 alpha and 3 beta. B says alpha squared and beta squared. Yeah, so let's start with A. So the question says we should find the equation, the new equation, alpha and beta, and the new roots are 3 alpha and 3 beta. So what we have to do here is the sum of all roots. What is the sum of all roots? Alpha plus beta. Well, let's write it. Sum of all roots, SOR, is equal to alpha plus beta, which is the sum of the all roots, because we said the roots were alpha and beta. When you sum this all, alpha plus beta is equal to minus B on A. Minus B here, okay, equal to minus. B is minus 5, so minus B is 5. 5 on A is 1, so that is just the same like 5. So alpha plus beta is equal to 5. The product of all roots is equal to alpha beta. Alpha beta is equal to C on A, actually. So C on A is 4 on 1, which is 4. 4 divided by 1, 4. So, yeah. When you have these two, then you can proceed with what was given to you. What was given to you is 3 alpha. What is the product of new roots? Product of, sum of new roots. Let's start with the sum. Sum of new roots is 3 alpha plus 3 beta. You can see that 3 alpha plus 3 beta is the same like 3 into alpha plus beta. But alpha plus beta is 5. So it is 3 times 5, which is 15. As the sum of new roots has 15. New roots. The product of new roots is going to be 3 alpha into 3 beta. When you simplify this, you are going to have 3 times 3 is 9. 9 alpha beta. But alpha beta is 4. You mean 9 times 4, that will be 36. So you have your sum of all roots, product of all roots, sum of new roots, product of new roots. So they're asking for the new equation. The question says, given the roots of this equation to be alpha and beta, find the equation. So we should find the new equation with integer coefficients whose roots are this. So if the new roots are this, these are the values that we are going to have. So what is the formula for new equation? Well, I don't want to write it all. New equation is equal to x squared minus sum of new roots plus product of new roots. Or let me put the O's, sum of new roots plus x. There's an x here. Sum of new roots x. Okay, let me just write it. Sum of new roots x plus product of new roots equals 0. So our new equation is going to be x squared minus sum of new roots 15x plus product of new roots 36 equal to 0. So that is a new equation. Let's do the B part. The B part says, okay, the B part is just this. B part says the new roots are alpha squared and beta squared. So let's solve B on that. We already have a sum and the product of new roots as 5 and 4. So let's do the sum of new roots. Sum of new roots is going to be alpha squared plus beta squared. But we need this alpha squared plus beta squared in terms of alpha beta and alpha plus beta. That is why we did some useful relationships. There we showed that alpha squared plus beta squared is actually the same as alpha plus beta all squared minus 2 alpha beta. You can check it out. You open this bracket, I'm going to have alpha squared plus 2 alpha beta plus beta squared. And minus the 2 alpha beta in the middle, we're going to have alpha squared plus beta squared. So we put it in this form so that we can have alpha and beta, alpha plus beta and alpha beta only. Because in the form of alpha squared plus beta squared, you cannot just, some students take this alpha plus beta, this answer, and they square it and say it is this. It's not the same. It would have been the same if all of it was squared, not each value individually squared. So when you have alpha squared plus beta squared, you put it first in this form where you can see clearly alpha plus beta and alpha beta. Then you can solve. So that implies sum of new roots is alpha plus beta is 5. 5 squared is 25 minus 2 times 8. Is 17, I think. Yeah. So for the product of new roots, product of new roots is going to be, the new roots are alpha square and beta square. You are going to be they're going to be alpha square times beta squared, which is alpha beta all squared. Since it is multiplication, the squared can just be put out of the bracket. You have alpha beta all squared. So that will be equal to alpha beta is equation. The new equation is already this, which implies new equation is going to be, well, I don't want to write it on the same line. New equation is going to be x squared minus sum of new roots x. Our sum of new roots is 17. X plus product of new roots 16 equal to 0. Yeah. So this is A. So this is how, this is the type of question. This question is the type of question that you might see in the GCE. Yeah, some questions also have these things. You know, if you studied the trickier ones, you went deep into studies. So then we'll meet in the questions part of quadratic theory. So thanks for watching, and let's meet on the questions of quadratic theory. And keep learning with us on EducQuiz.